So in this video, we're going to graph the graph of the first trigonometric function y is the sine x. And in the previous video, we mostly talked about the radian measure, which is a new concept for measuring the angle rotation in terms of all real number. And also we talked about the three main trig functions, sine, cosine, and tangent, and how to figure it out. And we prefer to use the unit circle because the right triangle, where we talked about in our previous video, we could not measure the obtuse angle that is greater than 90 degrees using our right triangle. So we applied the unit circle, which is a circle with the radius, where the radius is half of the diameter of +1. So using this expression, we're going to graph the y is equal to sine x using all information we already got. So before we graph the y is equal to sine x, we need to review the properties and the definition of the unit circle on the coordinate plane with the x and the y-axis. So for the unit circle, just like we reviewed in our previous video about a lot of types of the angles on the unit circle and the definition of the unit circle, it has a special quadrantal angle, where firstly, when the angle rotation is 0, then there will be the starting line where the angle rotation will start. And as we rotate the angle counterclockwise direction, positive direction, when we rotate 90 degrees, it will be pi over 2 radians. And if we go 90 degrees more from 90 degrees, which is 180 degrees, we will note it in terms of radian, pi radian. And when we go 270 degrees from the starting line, then we call it as the 3 pi over 2 radian. And as we get back to the point where we started, we note it as 2 pi radian through 60 degrees, which is the end of the period on our unit circle. But the most important thing is this quadrantal angles or the points has its own points or coordinates that is foreign with x and a y value. So according to the unit circle's definition, the radius are always equal to 1. That means every 4 points that we just looked at will have a coordinate. The x value will be 1 and the y value 0 when the angle rotation is 0 or 2 pi. And the reason is because the length from the 0 to this point will be 1 according to the definition of the unit circle, because this is a radius for a circle, and it is on the x-axis but positive, so it will be 1, 0. And if you go 90 degrees more, it will also become the length of 1, where we rotated pi over 2 radians. Then it is on the positive y-axis, so for a coordinate, it will be 0, 1, which is a y-intercept. And if we go 90 degrees more, where we reach pi radian, 180 degrees, then it will be -1, 0, because even though this length is +1 in terms of distance, but in terms of the coordinate, this will be -1. So it will be the negative x-intercept with the coordinate -1, 0. And lastly, if we go to 270 degrees, where the length is also -1, then the coordinate will be 0, -1, which is a negative y-axis. And using this information, we can define the sine, cosine, and tangent. So after erasing these values, let's think about random rotations of our angle in terms of radian. Think about the random angle rotation where we're going to note it in terms of the data. And theta will be an angle in terms of radian on our unit circle. Then we can realize that because of the proper unit circle, this radius will be equal to 1. And for this point that contains the coordinate x, y, to think about it, we can make a straight right triangle and think about the 3 trig functions, sine, cosine, and tangent. But before we do it, we can figure out that the adjacent side of our mean angle theta, we'll just notate it as the x coordinate or the x value. And the side that is opposite with our mean angle theta, we'll notate it as the y coordinate, which stands for the y value. And from here, we can define all three trig functions just like we did in our previous video, where the sine of our mean angle theta, secondly, the cosine of our mean angle theta, and thirdly, the tangent of our mean angle theta. And on the coordinate plane and on our unit circle, just like we made a definition in our previous video about the unit circle, the sine theta was the y over r, which is the y coordinate over the radius of our circle. And the cosine theta was the x, which is an adjacent side of our mean angle, over the r, which is the radius or the hypotenuse inside the right triangle. And tangent theta was the ratio between sine and cosine, which was y over x. But in this case, we need to know that the r, which is the radius for our unit circle, is equal to 1. The r should always be equal to 1 inside our unit circle. So because of that, sine theta will be y over 1, which is equal to y. And cosine theta will be x over 1, where the radius or the radius of the unit circle is 1, where we're going to get the x value. And the tangent y over x is a slope of the trigonometric function on the unit circle. So that means the sine theta on the unit circle is the y coordinate, and the cosine theta is the x coordinate, and the tangent value will be the slope in the trigonometric unit circle. So that means we can think about the point here, where usually if the x position was x and the y position was y, we can replace it in terms of sine and a cosine. So for the x and the y, that can be replaced because the sine theta is y and the cosine theta is x. So this point here can be notated as the cosine of our mean angle theta, comma the sine of the mean angle theta, where the cosine theta is the x coordinate and the sine theta will be the y coordinate. And this is the basic review for the unit circle, where we're going to use this information to graph the graph of the y is equal to sine x on the coordinate plane. All you have to remember is that the sine theta on the unit circle is the y value, and this only happens on the unit circle, where your radius is equal to 1. And we need to remember that the cosine theta value is x value, and the tangent value, which is the ratio between sine and a cosine, will be the value of the slope. So for the matter of spaces, let's shrink our unit circle and move these three values, or sine, cosine, and tangent, below our unit circle, and start thinking about how to graph the y is equal to sine x graph. So when we say that we need to graph the graph of y is equal to sine x, then we're thinking of the sine as a special function that requires a specific x value or the input to generate the output. And when we say we want to graph the y sine x graph, then we're plotting every y coordinates, which is the sine value, on the unit circle. And the reason is because we defined that the cosine theta is the x coordinate and the sine theta as the y coordinate. So it is same thing with plotting every single possible y coordinates on the unit circle. And to do it, we need a specific points, and we use the quadrantal angles. And the quadrantal angles are the points or the coordinates that intersect with the axis, just like we did review, which is this point here, where the angular rotation is 0 or 2 pi radian, where the point is 1, 0. And when we rotate 90 degrees and reach pi over 2 radian, with the coordinate 0, 1, and after we rotate 180 degrees total, which is pi radian, where the coordinate is -1, 0, and lastly, the 0, -1, where the angular rotation is 3 pi over 2 radians. And using these points, which are totally 5 points, including 2 pi radian, we'll be able to graph the collection of y coordinate, which is y is equal to sine x graph on the coordinate plane. So there are totally 5 quadrantal angles that we're going to use it as the central angle rotation for graphing the y sine x graph. Firstly, when the angle rotated 0, right here where the coordinate is 1, 0, the 1, 0, and there is the second angle where the coordinate or the angle rotated 90 degrees pi/2 radians, where the coordinate is 0, positive 1 right here. And thirdly, for the pi radian, where we rotate the angle 180 degrees from the straight line, where the coordinate is negative 1, 0. And fourthly, when the angle rotated 3 pi/2 radian, which is 270 degrees, then the coordinate will be 0, negative 1 like this. And lastly, as we finish the period for the unit circle, where we reach 2 pi radian, which is 360 degrees, as the end of the period or the cycle, then the coordinate will be 1, 0. And from this coordinate, what we're going to do is we're going to define the following cosine and sine values for graphing the sine value. So we define that the cosine value is an x value and the sine value is the y value. So if the coordinate is 1, 0 when the angle rotation is 0, then we could figure out that the cosine of the main angle, cosine of 0, will be 1 because the x value is 1 and on the unit circle the cosine is x. And secondly, the y value is 0, that means the sine of the main angle, 0, will be equal to 0. Secondly, when the angle rotated pi/2 radian with the coordinate 0, positive 1, the x value is 0, that means the following cosine of the main angle, and the main angle rotation is pi/2 radian, is equal to 0. And the sine of our main angle, pi/2, which is 90 degrees, is equal to 1, since we know that the sine value is the y value. Thirdly, as we rotate the main angle as pi radian, then the x value is negative 1. That means the cosine of the main angle pi radian is negative 1, and the sine of the main angle pi radian is going to be equal to 0. Fourthly, when we rotate the angle 3 pi/2 radian to 70 degrees, then the coordinate is 0, negative 1, where the cosine of the main angle 3 pi/2 radian is equal to 0, and the sine of the main angle 3 pi/2 or 270 degrees in terms of degrees will be negative 1 as a y value. And lastly, as we finish the period as 2 pi radian and hit 360 degrees, then the coordinate will be 1, 0, where the x value, the cosine of the 2 pi radian, is equal to 1, and the sine of the main angle, which is 2 pi radian, will be equal to 0. And this is how we define the 5 total quadrantal angles that we're going to use for graphing the sine axis graph. But we're right now graphing the y is equal to sine x graph, so only thing that we need to care about is the sine value. Firstly, when the angle rotation is 0, then the sine of 0 is 0. Sine of 0 is 0. When the angle rotation is pi/2 radian as 90 degrees, then the sine of the main angle pi/2 radian is 1. And the pi radian, when the angle rotated 180 degrees, then the sine of the following angle pi is 0. Fourthly, when the angle rotated to 70 degrees as 3 pi/2 radian, then the angle rotation was sine of 3 pi/2 is negative 1. And lastly, when the angle finished its period as 2 pi, then the sine of 2 pi will be equal to 0. And using these 5 values of sine, we'll be able to graph the y is equal to sine axis graph. We're graphing the y is equal to sine x. The x value, which is a special input, is not the cosine value on the unit circle. The x value are these values such as 0, pi/2, pi, 3 pi/2, as well as 2 pi, which are the angle rotations on the unit circle. And for this y value, which is an output that has been generated from the x, which is an angle rotation, will be the following sine value. So sine of 0 will be 0, sine of pi/2 is 1, when the x is pi, the y value for sine is 0. And for the 3 pi over 2, when the angle rotation is 270 degrees, the following sine value will be -1. And lastly, when the angle finishes its rotation as 2 pi, then the following sine value will be 0. So 0, pi over 2, pi, 3 pi over 2, and 2 pi radian will be the input, and 0, 1, 0, -1, and 0 will be the y value for the sine x graph. So using this information, let's graph the y sine x on the coordinate plane. When the y value, the x value is 0, which is an angle rotation, then the y value following sine value is also going to be 0. So for a sine graph, it will always start off the origin. And as the angle increases and reaches pi over 2, which is 90 degrees, then the following sine value will have its maximum point as a positive 1. And that will happen when the x value is pi over 2 radian, which is 90 degrees. Thirdly, when the angle even increases and hit 180 degrees, then the following sine value will get back to 0 when the x value is pi radian. Fourthly, when the angle rotates 270 degrees as the x input, then the following y value, which is the sine, will have its minimum point as a -1. And the -1 is the value of the y as the sine when the angle x is equal to 3 pi over 2 radian. So the y value will be right here as the -1. And lastly, when the angle finishes its period as 2 pi over 360 degrees, then the following sine value will get back to 0. And this is the first period of the sine graph, or as the first period on the unit circle. So if we draw a curved line between 0, pi over 2, pi, 3 pi over 2, and 2 pi radian, we will form a first period of y is sine x graph. This is the curved line for the y is equal to sine x. And for graphing the y is equal to sine x, the definition of y sine x is plotting all of the y coordinates on the unit circle. So this is basically originated from the unit circle, so let's compare its values. When the angle rotation is 0, so when the angle rotation is 0, then the following coordinate is 1, 0, where sine value is the y coordinate. So the sine value is sine of the 0 is equal to 0. So our sine value start from the 0, which is the origin. And secondly, when the angle rotates 90 degrees, which is pi over 2 radian, and hit this point, which is 90 degrees with the coordinate of 0, +1, then the y value, which is the sine of the main angle pi over 2, will be equal to 1. So when the x value is pi over 2 radian, then the following y value will have its maximum point as a +1. Thirdly, when the angle rotations rotate, so when the angle rotates 180 degrees, like that, and reach pi radian with the coordinate of -1, 0, where the y value, which is 0 in this case, is the sine value for the main angle, pi radian. So when the angle rotation, which is the angle input x, the y value, which is the sine pi value, will get back to 0. Fourthly, when the angle rotates 90 degrees from 180 degrees, which is 270 degrees, 3 pi over 2 radian, then the angle that point's coordinate will be 0, -1, where -1 is the y value for the sine of the main angle, 3 pi over 2 radian. So as we can see, when the x value, which is input in this case, is 3 pi over 2, then the y is equal to sine x graph will have its minimum point as -1. And lastly, when it finishes its period as 2 pi, where the 1, 0 its coordinate, the sine of that 2 pi will be equal to 0. And like this we could compare the y is equal to sine x graph with the unit circle, because y is equal to sine x graph was originated from the unit circle. With the definition, the sine graph is the collection of the y coordinate on the unit circle. So let's think about the properties for this graph y is equal to sine x. When we're thinking about the graph, the first thing to talk about is the domain for the function. And for the domain, it stands for the every single possible the x values can become on the functions. And when we're thinking of the sine graph, the x values is the angle rotations. So when we're thinking of the angle rotations, especially in unit circle, when the angle rotates, it can either start from the starting line and go counterclockwise direction, positive direction to the infinity. And also for the negative angle rotations from the starting line or initial line can go clockwise direction infinity times. So that means the domain can be notated from the positive negative infinity, and this angle rotation on the unit circle will be notated on the graphs as the x value. So firstly, for a positive x infinity from the 0, it will go all the way to the positive x infinity value. And for the negative, which is a clockwise direction rotations, it will start from the 0 and it will go all the way down to the negative infinity. And including the positive and negative infinity, we notate it as the all real numbers. So the domain for the sine graph will be all real numbers. And we need to remember that the domain of the sine graph is all real numbers, also a angle rotations on the unit circle. And the second thing to talk about is the range. And for the range, if the domain was the all set of possible x values, then the range will be all set of possible y values. So when you're thinking of the range of the sine graph, then it is the same thing with saying the y values in the graph. That means the domain for the x value is going to be all real numbers as the angle rotation on the graph. So from the 0 as the angle, or another way to say the x value on the y is equal to sine x graph increases and hit pi/2, then the following y value will also increase and reach its maximum point as positive 1, and the y value, or another way to say the sine value, will hit its maximum point as positive 1 when the x value is pi/2 radian. However, as the angle rotations, or the x value in y is equal to sine x, even increases more and reach pi radian, which is 180 degrees, then the sine value will start to decrease and finally reach the 0. And it will finally reach the 0 when the angle rotated pi radian. And as the angle even more rotated and hit the 3 pi/2 radian, which is 270 degrees, then the sine value will start to decrease and have its minimum point as -1 when the x value, or the angle rotated 3 pi/2 radian, or 270 degrees. So the angle, as it rotated 3 pi/2 radian, the following y value will be -1. And it will be its minimum point on the graph. And as the x value increases and finally reach 2 pi radian as a end of the period, then the y value will start to increase and it stops at the 0. And this will be the range. The range is the y value on the sine graph, while the x value is the angle rotation. And its maximum point is positive 1, and its minimum point will be -1. So now let's compare the things we saw in the y is equal to sine x graph with the unit circle. The first thing we're going to talk about is the x value from the negative infinity to the positive infinity x value of y sine x graph. As we already know, the x value in y is equal to sine x graph is the angular rotations on the unit circle. So angular rotations mean from the initial line or stern line, the angle can rotate the positive infinity angle rotation, or it can also rotate negative direction infinity times. So the x value on the y is equal to sine x graph is the angular rotation on the unit circle. And one thing we need to be careful is the term on the unit circle, that is the x value, is the angle, because the x value on the unit circle, or the x coordinate, is the cosine theta. So the x value on the unit circle and the x value on y is equal to sine x graph is completely different. So the x value on the unit circle will always be the cosine theta. The next thing to talk about is what is the y value for y is sine x graph. We already know that also in the unit circle as well as the graph, the y value is going to be the sine theta value. And same thing with the graph of y is equal to sine x. The y value will be the sine theta that has been generated with the special input, which is the angular rotation on the graph of y sine x graph. The next thing to talk about is the y sine x starts from 0, and as the angle increases, and when the angle, which is the x value on the y sine x graph, hits pi over 2 radian, then the maximum point will be positive 1. And let's see what the sine value of the main angle, pi over 2 radian, just like we saw in the y sine x graph. We can figure out that the sine value of the main angle 90 degrees pi over 2 radian, which is the y value on the graph, is equal to positive 1 as its maximum point. And as the angle keep increases but the y value decreases, and finally reach the point right here when the x value hit 3 pi over 2 radian, and the y value will be equal to -1 as its minimum value. So let's think about the sine value of the main angle rotation 3 pi over 2 radian on the unit circle. Now, as we can see, the y value, which is -1, as the sine value is its minimum point as -1, and we could verify through the y sine x graph and on the unit circle. Next thing to talk about is the period for the y sine x graph, and the period is the most important thing when we're thinking of the trigonometric function graph, especially in a y sine x graph. And the period means, so for a y sine x, it always starts off 0, and as the angle increases, then it will have its maximum point as positive 1 when the angle is pi over 2 radian, or also the x value, and it's the x also increase and go back to the 0 again. And as the angle reached 3 pi over 2 radian, then the following y value is -1 and get back to 0 as the angle finish its period. And from 0 to pi over 2 to pi radian, and to 3 pi over 2 radian, and all the way to 2 pi, which means from 0 to the 2 pi radian, this form will be continued to the right and the left side, which is positive, and the negative side, and keep going on, and that is going to be the period for this function. That's why we call the sine x as a periodic function. So we graph the y is equal to sine x, first period from 0 to 2 pi on the positive direction, and it will keep going on to the positive axis too. And now let's graph the first period from 0 to -2 pi after shrinking this graph. So the graph that is being formed 0 to 2 pi radian with the period of 2 pi radian will be continued to the left side infinity and the right side infinity. But in this case, I'm going to draw the also another sine function that continues to the right side infinity, which means positive infinity direction, with the same graph as the same period, like this. So this graph starts from 2 pi because the original graph started from 0 and finished at 2 pi. So this graph starts from 2 pi, and as the angle increases and reach 5 pi over 2, it will have its maximum point as a positive 1, just like the original graph where it had a positive 1 when it was pi over 2 radian. And as the angle increased but the y value decreased, just like the graph, the original graph where we draw from 0 to 2 pi radian, so it stops at 0, and then the angle increases and his 7 pi over 2 as its x value, then the y value will have its minimum point as -1, just like the original graph we graphed from 0 to 2 pi, where it had its minimum point when the x value was 3 pi over 2 radian, and as the x value, which is an angle rotation on the unit circle, hits 4 pi radian, which is the end of the period, it will be equal to 0 again, just like this graph right here. So this graph started from 2 pi and ended at 4 pi. That means it has the period of 2 pi radian. Firstly, if you review the properties of y is equal to sine x graph on the current plane, we can figure out that the domain, which is all set of possible x values on the graph, is all real values, all real numbers. That means from the negative infinity to the positive infinity, which is the domain for the y is equal to sine x graph, will be all real numbers. And this is the domain for the y is equal to sine x graph. Secondly, if you think about the range, which is the y values, all possible y values on the y is equal to sine x graph, it has a limitation where the y value cannot go under the minimum point, which is -1, for example right here and right here. So y value cannot go under the minimum point -1, but cannot go over the maximum point, which is +1 right here. So the y value should be always between -1 and the +1, which are the minimum and the maximum point. Now the another thing to remember is we might get confused the domain, which is the all set of x value from the negative to the positive infinity. In the y is equal to sine x graph, it is the x value. However, on the unit circle, it is the angle rotation, and the x value on the unit circle is cosine theta, which is completely different with the x value on y is equal to sine x graph. Y is equal to sine x graph's x value is going to be the angle rotation on the unit circle, and the x value on the unit circle will be the cosine theta value. Now, when you think about the range of the y is equal to sine x graph, it is exactly same with the unit circle, where the y value will be the following output of sine when we input the angle rotation, and the angle rotation is the domain inside this graph of y is equal to sine x graph. And lastly, the most important thing, which is the period of the y is equal to sine x graph. For the period of y is equal to sine x graph, the form from the 0, for example, it always starts from the origin. So from the 0 to all the way to 2 pi radian, which means the 2 pi radian will be the period for y is equal to sine x graph, and the period means after a certain graph is formed. In this case, 0 to 2 pi, it will continue to the positive and the negative direction, and this 2 pi radian will be the period for y is equal to sine x graph. That means if we make a square form between these two terms, from this one all the way to this length, inside this box it is one period from 0 to 2 pi, and from 2 pi to the 4 pi radian, which is the another period, which is also going to be have a period of 2 pi radian. These are the periodic function of y is equal to sine x graph.